So this first one here is find the identical expression for the following: sine times secant plus cotangent. And so let's see. So question 1, sine x times secant x plus cotangent x. It looks like in a weird place, that plus. There we go. And that's going to be sine x times, and now I'm going to use the reciprocal identities, so cosine x plus this one here is cosine x over sine x, and then I distribute the sine x, so I'm going to have sine x divided by cosine x plus, and then that one is cosine x because the sine x of course divides out, and then I check the possible solutions here, and it's going to be the first one because this one here of course is tangent. Okay, the next one, this one here is really similar to that one, and on this practice exam I may not do all of them if it turns out that the following problem is really similar. Here I'm going to make an exception. So sine squared x times cotangent squared x plus 1, and that equals sine squared times, and here recognize that that is a Pythagorean identity, so cosecant squared x. As I said, that's a Pythagorean identity. And of course the cosecant is the reciprocal of the sine, so sine squared x times 1 over sine squared x, and that of course is 1 because the sine squared divides, and that one is one of the possible answers. By the way, even if I didn't know that particular Pythagorean identity, I can do it as follows. I'm going to change the color on this one. Even if I didn't know that, I could do the following: equals sine squared x times cosine squared x over sine squared x, that one I do have to know, plus 1, that is the ratio identity, and then of course on the first one the sine squared divides, so it's going to be cosine squared x, and on the second one when I have distributed it, that is sine squared x, and that one I do have to know, that Pythagorean identity I have to know, even if I didn't know the other one. I would have to know that one. And when I check the answers, that answer 1 is indeed there. So here's question 3. So let's see. See instructions for these here. You only get points if you show the algebra in the editor box. Find the identical expression for the following, and so this one is 1 minus cosine to the 4th divided by 1 plus cosine squared, and I give away here that this one is already the correct answer. If I didn't do that, you would have to figure out each one of them is not the correct identity, therefore it would be a false statement, and only this one is, and that's actually more work than showing the algebra behind just the correct answer. So I'm going to pick that one, So that one is going to be 1 minus cosine to the fourth divided by 1 plus cosine to the squared theta equals apparently sine squared theta. Okay, and then I'm going to open this one here. And let's see what it says there. Okay, there it is. Show that this is an identity. Hint: the numerator can be interpreted as a difference of squares. Okay, I guess I can just stay right here and don't have to go back to that writing program. Alright, so the numerator can be interpreted as a difference of squares, so the denominator is going to turn out like this: 1 plus cosine squared x and 1 minus cosine squared x divided by 1 plus cosine squared x. And then I should say here left side. Okay, and that was difference of squares, and then I recognize that this one here divides with this one, so that one is the answer on the left hand side, and I see that that is sine squared because that is the Pythagorean, or one of the Pythagorean identities, and this is what I ask of students to do. Type this out just the way I do it. You don't have the luxury of handwriting it. Using an equation editor would be asking too much. You don't have to figure out how to use an equation editor just for this problem or for these problems, but just typing straight on the keyboard is required. And then you can leave it either in this document and email it to me, or I can go back to the test and go to this last question, and this is for question 3, where I just added that in. Okay, I'm not going to do number 4, 15, and 16 because these would be done in the same fashion and would be also showing the kinds of identities that they're doing in this chapter. So I'm not going to do number 4 here. Let's see, number 5 says, use a graphing calculator to determine if the equation appears to be an identity or not by graphing the left expression and right expression together. So I'm going to go to the graphing calculator. Okay. So y equals, and then I'm going to have the left hand side would be cosecant. So I'm going to have to shift this a little up because there's, oh, there we go, that's better. Okay, so cosecant is the same as 1 over sine. I don't have a choice on my graphing calculator, minus cosine of x. There we go. That's the left hand side, and then the right hand side is cotangent, which is 1 over tangent. So again, I don't have a choice. I have to type it in this way. And then times cosine of x. Okay, and then I'm gonna see that I'm in radians. I could be in degrees. Radians is a little bit more convenient because I can just go from 0 to 2 pi, for example. And scale really doesn't matter. The y minimum, I don't know, maybe I go between -2 and 2, anticipating that I have an amplitude of 1, maybe a little bit larger. And then I graph, and there's the left-hand side graphing. Still the left-hand side graphing. And there's the right-hand side graphing, and that is definitely not the same. And therefore, this one is not an identity. I may want to double check if I actually typed them in correctly. And this one is 1 over sine is a cosecant, and then minus cosine, and the other one is 1 over tangent is the cotangent times cosine. So I did type it in correctly, and this one is not an identity.